Alright, today we're going to be looking at a freefall problem and several questions associated with it. Now this is assuming that you've had a little bit of background with the kinematics equations and that you can do them in one dimension. We're still going to be doing one dimension, but this time we're going to be going up and down rather than side to side. Okay, so let's start off by reading the question, which says we've got a stone that's been thrown from the top of a building. So I'm going to go ahead and draw a picture because I work better with pictures. So I've got a picture. There's my building. Stone is thrown upward with a velocity of 20 meters per second. Okay. It goes up, comes up to the top, comes back down. Guess we're assuming that it's almost straight up because the stone just misses the edge of the roof on the way down. So then it's going to fall all the way down, and we know that the building is 50 meters tall. Alright, so there, we've got that. So let's go ahead and work on the problem now. So it says first we want to know the time needed to reach the maximum height. So that's right there. Alright, so it goes up. How long is it going to take it to get there? So I already know that my initial velocity is 20 meters per second. Okay. Now I don't know how long it's going to take me to get up there. I don't know how far that is either. But I do know that my acceleration is negative 9.81 meters per second squared. It's negative because gravity is pulling down. And so since my initial velocity is positive going up, then the negative denotes that the acceleration is downward. The only other piece of information I have is that when it gets to the top of the peak, it's going up, 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 slowing down, slowing. It stops, and then it starts coming back down. It doesn't stop for any given period of time, but in an instant at the very top of its peak, the velocity is 0 meters per second. And so since I'm looking for time to get to that point when it's at rest, then I'm going to say, okay, I need now the time. So I'm going to find my kinematics equation that relates velocity, acceleration, and time, which is going to be the first one that we had in our class, which is v equals initial velocity plus acceleration times time. So then we can go ahead and put the numbers in. 0 meters per second is equal to the initial velocity 20 meters per second plus the acceleration, which is negative 9.81 meters per second squared, times the time. We'll subtract the 20 to the other side, so we'll have negative 20 meters per second is equal to negative 9.81 meters per second squared times the time. We'll divide both sides by negative 9.81, so here we go. We'll take negative 20 and we'll divide by negative 9.81, and we will get an answer of 2.03, so we'll say 2.04. So t equals 2.04 seconds. And so there's the answer to part A. So let's go into part B. What is the maximum height? So we're still looking at the same position, so we can still use all of this information, but now we also have the time. So really we can use any of those equations that involve velocity, acceleration, or time. So the easiest one is probably going to be, let's use one of the ones that we know is going to be on the AP exam. So that's going to be the x equals x initial plus v naught t plus 1/2 at squared. We know that initially it's 50 meters up. So 50 meters plus the initial velocity, which is 20 meters per second, times the amount of time, which was 2.04 seconds, plus 1/2 times negative 9.81 meters per second squared, times the time squared. I didn't quite have enough space, 2.04 squared. So that we can just punch right into our calculator. So we'll say 50 plus 20 times 2.04 plus 1/2 times negative 9.81 times 2.04 squared, and we get the answer of 70.38 or 70.4. So x equals 70.4 meters. So that's the maximum height. Now, of course, that's including the cliff, because we said that we started 50 meters up. So now the question is the time needed for the stone to return to the level of the thrower. Okay, so now we know that we're starting at a height of 50. We know that we're ending at a height of 50, okay, which means that in any of our equations the change in displacement is going to be 0 meters, right? And then we have the same initial information. Initial velocity is 20. The acceleration is still negative 9.81. Okay, and so now we can calculate the time needed. And so we've got displacement, velocity, and acceleration. We don't have the time, so let's use, we're looking for the time. So we want time, so our equation needs to have time in it. So let's use the same equation. So we're going to use x equals x naught plus v naught t plus 1/2 at squared. Okay, so we'll go ahead and plug in those numbers. So we'll have 50 meters. The final is 50 meters as well, so equals 50 meters plus the initial velocity, which is 20 meters per second, times the time, which is what we're looking for, plus 1/2 times the acceleration, negative 9.81 meters per second squared, times time squared. We'll subtract the 50, which means that 0 is going to be equal to 20 times t plus 1/2 times negative 9.81. Go ahead and do that. So 0.5 times negative 9.81, so negative 0.905. Okay, so minus 4.905 meters per second squared times t squared. You'll notice they both have a t. You could use the quadratic formula here. You can factor out a t. You shouldn't divide by the t because that's going to get rid of a solution mathematically. We can factor out the t, which will give us 0 equals t times 20 minus 4.905 t. So since both of this times this equals 0, then one of those has to be equal to 0. So t could equal 0, or 20 minus 4.905 t equals 0, which means t could also be 20 divided by 4.905, which gives us 4.08 seconds. Which, interestingly enough, this was the starting point, right? We started at 50 meters, so that's why you got a 0. So that's not really our answer. 4.08 seconds, which is exactly double the amount of time it took you to get to the maximum height. So we learn from this that any time an object goes up and comes back down, since the acceleration is constant, that means that the amount of time it takes to get to its maximum point is going to be the same as the amount of time it takes to get from the maximum point back to where you started from. Okay, and so we have that. And let's try letter D. What is the velocity of the stone at this instant? Okay, well, some of you can reason through this and you say, well, I started out with a certain velocity. It's accelerating with a constant acceleration for 2.04 seconds and gets to 0, which means that there was a change of 20 meters a second, right? It went from 20 meters a second to 0 in 2.04 seconds. The acceleration is remaining constant. If the acceleration is remaining constant, then with the next 2.04 seconds, the velocity should change exactly the same amount as it did in the first 2.04 seconds, which means that when it reaches that point, it should have a velocity of 20 meters per second down, which is negative 20 meters a second. 20 meters a second less than the first time. But just to check that out, we'll go ahead and put it into equation. So we need an equation that has final velocity in it. Nice one is probably this one right here. V squared equals the initial velocity squared plus 2a and then x minus x naught. Okay, and so that should be pretty straightforward that when you do that, v squared is equal to the initial velocity, which was 20 meters per second, squared, plus 2 times negative 9.81 times 50, minus 50, right, which is going to be 0, which means this whole term is going to go away. So v squared equals 20 meters per second squared. Take the square root of both sides. You get the final velocity as the square root of this. Now remember, when you take the square root of a variable, it could be plus or minus. So initially it's up at 20 meters a second. Final is negative because it's plus or minus mathematically. We understand that the plus 20 meters a second is when it's at this point right here going up. At this point going down should be the negative. So the velocity is negative 20 meters per second. So I hope those 4 examples are helpful for you in your homework tonight. And if you have any other questions, just let me know in class. I'll talk to you guys later.